right? So we'll study about two types of index techniques in today's class: primary index, which consists of sparse index and dense index, and then we'll study about secondary index. So what do you mean by primary index? So if the index is created on the basis of the primary key of the table, it is known as primary indexing, right? So you all know that there will be some primary key in a relation, and if you are going to create an index based on the primary key of the table, it is known as primary indexing, right? So these primary keys are unique to each record, and it contains 1:1 relationship between the records, right? So again, the primary keys are stored in a sorted order. The performance of the searching operation is quite efficient. So the primary index can be classified into two types, namely a dense index and a sparse index, right? So whenever you are going to create an index structure with the primary key values of a table, it is known as primary index. So there exists a 1:1 relationship between the records, like there exists an 1:1 relationship between the search key and the records in the case of primary index, right? Again, you are going to store the records in a sorted format. So the searching is quite efficient in the case of primary index. So in primary index, we have two types, namely sparse index and dense index. So what do you mean by dense index? So dense index means you have a search key for each and every record that is being present in the uh, table. It's known as dense index, right? Whereas in the case of sparse index, you have only a few index values for the records that are present in the table. So we'll see with an example the difference between dense index and sparse index, right? So the dense index, it contains an index record for every search key value in the data file, right? So it makes the searching very faster, right? So for example, you have some instructor table containing instructor ID, name, department, and salary. So let us assume that the search key value, or here the prime key attribute, is going to be the instructor ID. So if you are going to have index record for each and every search key value in the data file, right? So it contains the index structure contains the search key as well as the pointer to the particular record. So since you contain since it's a dense index, it contains index record for each and every search key value in the data file. It is known as a dense index, right? So since it contains pointer to each and every record, the searching is going to be quite faster, right? So in this, the number of records in the index table is same as the number of records in the main table, right? So all the records in the main table, they have an index in the index table. Hence it needs more space to store the index record itself, right? So here the trade of the difficulty is that you need to have a lot of space devoted to storing the index file itself, right? So the index records have the search key and a pointer to the actual record in the disk, right? So this you can visualize, right? So generally an index file, it contains the search key. It contains two columns. One is going to be the search key, and next column is going to be the pointer to point towards the location of the search key in a particular record that is present in a disk, right? So this is an example of a dense index where we are going to create an index file based on the faculty ID, right? So you can also create a dense index with a search key department name on instructor file, right? So you are going to create a search key for each and every department, right? So in biology department, you have only one instructor associated with the biology department, whereas you have three faculty members associated with CSE department, one associated with electrical engineering, and so on. So again, this is an example of a dense index with search keys department name on instructor file, right? So the previous example was dense index with search key instructor ID on instructor file. So instructor ID is going to be the primary key. So you have uh, so you have the search key or the search key for all the instructor in the index file, right? So the next is going to be a sparse index. So in the case of a sparse index, the index record appears only for few items. So in the case of dense index, the index record appears for almost all the records that are present in a disk. Whereas in the case of sparse indexing, the index record appears only for few items, and each item points to a block, right? So in this, instead of pointing to each record in the main table, so the index points to the records in the main table in a gap, right? So instead of pointing to all the records in the main table, here the index record points to the main table with some gap. So let us visualize how sparse index is being organized, right? So for example, here the structure of the index is going to be very small. So you have index being created only for three instructor IDs: 10101, 32343, 76766. Right. So the advantage here is that the size of the index file is going to be small compared to that of dense index, right? So however, there are some points that you need to note while you are going to use sparse index. So the sparse index can be used only if the relation is stored in a sorted order, right? So in the case of dense index, you can use it even if the relation is in unsorted format. Whereas in the case of sparse index, sparse indices can be used only if the relation is stored in the sorted order of the search key, right? That is if the indexing is a clustering index. So clustering means you are going to group similar data points together, right? So to locate a record, we find the index entry with the largest search key value that is less than or equal to the search key value for which we are looking, right? So for example, you want to access the record with the instructor ID 222252, right? So you are going to find the index entry with the largest value that is less than or equal to the search key value, right? So the index value should be less than or equal to the search key value. So we are going to pick 10101. Then from 10101, you are going to move to the next record, followed by the next record, and finally you get into the record Einstein with the values 22222, right? So we start with the record pointed to by that index entry and follow the pointers in the file until we get the desired record, right? So whenever you want to locate a particular record using a sparse index, you are going to start with search key value that is less than or equal to the search key value for which we are going to look, right? So you are going to traverse the index file. You are going to look for the search key value that is less than or equal to the search key value for which we are looking, and then once you locate a value that is less than the search key value, then from there onwards you are going to sequentially access the records and you are going to retrieve the record that we are interested.